Before we get deeper into testing, let's make sure we are familiar with some concepts around scaling. Throughout the course, I will use the terms system or application interchangeably. Typically, IT systems that need to scale are very complex and made out of various moving parts. A correct name to describe this would be IT system or simply system. However, for simplicity, I will also use the term application or simply app. Applications run on servers. If we simplify a bit, servers running an application are not much different from the computer you are using to watch this course. Did it ever happen for your computer to crash or for an application to freeze? When an application or a computer consumes too much computing power or memory, it can cause your system to crash. The same can happen to a server running an application when too many people try to use it at the same time. So, how can an IT system scale if it needs to handle more users? Let's make an analogy. Imagine a popular city that's attracting more residents every year. There's only one building in the city where everyone wants to live. Initially, there's enough space, but as more people move into the city, the building becomes overcrowded, leading to long waiting lists. To handle this increased population and demand, you decide to add more floors and expand the building space. This is called vertical scaling or scaling up. This is when you boost the capacity of a single server by adding more memory or using a faster CPU. Now, instead of just expanding one building, imagine constructing multiple buildings in the area. Each building can accommodate a certain number of residents, and together they can house more than a single building. This is called horizontal scaling or scaling out, where you add more servers to handle the increased load, distributing the traffic among them. In a nutshell, vertical scaling is like adding more floors to one building, while horizontal scaling is like constructing multiple buildings in the same area. However, with vertical scaling, there are physical limits in terms of how much we can scale vertically. As the higher you go, the more expensive it is. At one point, it makes no sense to continue scaling vertically. Apart from this, if you have a very powerful server that can handle even the most demanding days, in periods of low usage, you will have a lot of CPU and memory just sitting idle doing nothing. Scaling horizontally allows you to use multiple reasonably sized servers. When you have a higher load, you just use more servers. When the load decreases, you can simply use fewer servers. Cloud providers make this relatively easy to scale up or down and pay only for the resources actually used. It is often called elastic scaling. While horizontal scaling sounds very tempting, things are not so easy in practice. In particular, older applications tend to have a monolith architecture, meaning that all components of the application are tightly coupled and can only be deployed together on a server. So a monolithic application can't be easily deployed to multiple servers. Microservices are another architectural approach where an application is made out of loosely coupled components or services. This has the advantage that each server can be scaled up or down as needed. What you need to understand is that infrastructure costs need to be optimized. No company can afford to run a huge infrastructure that is used at only 10% apart from 2 weeks of the year, like during a popular event when these machines are really used at capacity. However, re-engineering a monolithic application to use microservices can be also a costly endeavor. So often companies need to choose between paying more for servers that sometimes sit idle or paying for development time in the hope that their infrastructure costs will decrease. There is no right or wrong. Each application might have different needs.